Here, everyone in already. I see a few people are not in here yet. Guys, just a quick recap of what we mentioned last week, guys. Okay, so basically we talked about a converging lens, right? Converging lens are basically, you can think of it as blocks of prism that is basically diverging light to one single part here. And this is essentially where a clear image is formed. In terms of our eyeballs, guys, in terms of our eyeballs, the reason some people have perfect vision is because the lens from our eyes is redirecting light to hit exactly at the back of our eye. Today, if you have perfect vision and you don't need glasses, the only reason is because your lens is working perfectly fine and it causes all the lights to hit exactly at the back of your eyeball and you see a perfect image here. But everyone else that have glasses, most likely is because your lens is not the correct size to your eyeball, and because of that, your light may converge at the front of your eye or your light may converge at the back of your eye. Depending on whether it is the front or back, you will either have short-sightedness or you will have long-sightedness here, right? But of course, yeah, you just need to know that by right, light is supposed to be here, then you'll have clear vision. Okay, this is supposed how your eyeball is supposed to be like. In terms of the lens here, I mentioned that there are 4 key things that you need to know of, guys, right? Definitely number 1, the optical center, which is the dead center of the lens, right? The principal axis, which is essentially the x-axis of the lens that separates the lens in half. The focal point, by definition, is where all the light rays are going to converge, guys. And of course, finally, the last part here before I ended today last week is the focal length, which some of you guys have given me a wrong answer. Always remember, guys, I say this, it sounds dumb, right? And it sounds like it's a very logical, but I've seen 1,000 students get this wrong, guys. God. Can you just like shove a slipper at the door and like they just come in themselves? Hey, 我 print 这东西给你们啊，等一下在那边拿，你们开始做那个 paper 4先。Okay. So guys, like I mentioned, pay attention. I don't want this to be ever wrong again. It is always the optical center to the focal point, which is known as the focal length. Not the optical center to the image, not the optical center to the object, not the optical center to wherever God knows where, guys. It is always from the center to the focal point here. Okay, very, very important. And then on top of that, I talked about the 6 major characteristics here. The 6 major characteristics include virtual or real. Guys, it is either virtual or real depending on the light that forms it, guys. Magnified or diminished, becomes bigger or smaller, upright or inverted. The more easier way to see this is going to be something like this. Well, guys, you see that all these 3 here that we mentioned last week, these are all definitely going to be real. Why are they real? Because they are formed by real light. You see these 2 real light converges and forms this image. Real light converges, form this image, real light converges and form this image here. This is going to be real. Now in your exam, they always like to ask you whether the image produced is going to be real or virtual. And pay attention, guys, I'm going to ask this later on. It will either be real or virtual if it can or cannot be projected onto the screen. Okay, for example, today this image, we say it is real. Your exam will ask you why. Why is it real? You cannot say because it is formed by real light, guys. No, you must mention that it is because this image can be projected onto a screen. This is essentially how the cinema works, right? You know, like the film from the small little thing will be projected onto the big screen, right? This is that big screen here, right? And this is the reason why this is going to be real. It cannot be real when you cannot project it onto the screen. For example, this one here is definitely formed by virtual light, right? The dotted lines represent virtual light. And if you think about it, if you ever play with a magnifying glass before, can you take that image that you see from the magnifying glass and project it onto a screen? That is definitely a no, guys. And because it is definite no, you cannot form virtual images onto a screen. Your IGs will always ask you this. Explain whether the image is real or virtual. This one here is definitely virtual. Why? Because it cannot be projected onto the screen. Is this image real or virtual? It is real. Why? Because it can be projected on the screen. Standard question with a standard answer. Make sure you all know how to do this. It is free damn marks, guys. It is free damn marks. You must know this. Right. And after that, I told you guys to draw the lens here. I hope most of you guys have drew it. You didn't draw your virtual light, Abigail. Yeah, yours is wrong also. Rachel, it should be a straight line here, then cut through the focal point, then only dot. You please refer to this image here, guys. I think some of you guys drew it wrong. Some of you guys didn't even draw it. Right. Yeah, please make sure you know how to draw it. But anyways, today we're going to discuss all the answers here after we're done with this final topic here, guys. The final part for this chapter here, before we move on next week to electromagnetic wave, guys, is essentially the dispersion of light. Now, dispersion of light is essentially why rainbows are formed. Guys, did you know that white light, which is from the sun, can form rainbows? Is because it contains 7 different wavelengths and 7 different frequency in the wave. They close the door, they're getting noisy. Yeah. Guys, pay attention now. White light can go through dispersion because white light itself contains 7 different wavelengths, guys. Essentially, after the rain, you'll see rainbows form, right? Usually, the raindrops will act as a prism. I mean, it's gonna look something like this. Imagine this is a raindrop. Right, and then this raindrop here is essentially separating white light into 7 different colors. Why will it be separated into 7 different colors? Is because these 7 wavelengths when they are refracted, they will be moving at different speeds. If you think back about the formula for waves, guys, V equals to F lambda, right? V is equals to F lambda. We all remember this formula, right? If the frequency is the same, which I've mentioned, it doesn't matter reflection, refraction, or diffraction, frequency will always be the same, right? Today, a decrease in a wavelength here is actually going to cause the speed to decrease. And because these 7 different colors have 7 different wavelengths, they will all have different speeds. And because of that, they will all be refracted at different angles when they go through refraction. Okay, I repeat, these seven colors, right, all have 7 different speeds. And because they all have different speeds, they will all be refracted into 7 different angles, guys. Now, today we understand that white light can be refracted at 7 different angles to form 7 different lights, right? It is possible, guys, to combine all 7 colors back into a white light again. Anyone here played with this experiment in kindergarten before? Anyone know what I'm talking about? Or combining? Do you know how to combine 7 colors into white light again? Good, as I thought. None of you guys ever played with this before. Let's go to YouTube. Today, guys, if I say that you can combine 7 different colors, I don't mean that you're gonna draw 7 different colors onto a white piece of paper and then it's gonna turn into white color. No, most of the time it'll turn into a brown color or black color or something like along the lines. That's definitely wrong, guys. How do we combine 7 colors? Is by spinning the 7 colors in a relatively fast speed, guys. For those who've never done this before, basically what you're actually supposed to do is, right, you're supposed to take this piece of cardboard, right, and you're going to color it with 7 different colors. When you color it with 7 different colors, right, you're going to poke specific holes onto it, right, so that you can put some strings into it, and essentially you're going to get something like this at the end of the day, You'll get something like this at the end of the day. So when you get something like this, right, what you're going to do is you're going to wind it up. You're going to keep spinning in one specific direction, and eventually you can start pulling the strings. When you start pulling the strings, right, what happens is these 7 different colors will all be moving at very fast speeds, and if the speeds are fast enough, it will actually go back into white color, as you can see from this video here. Let me just mute it. Everything else is irrelevant. See this guy here? When he starts spinning it at very fast, you can see that it starts going back into white in color, guys. This is because white light is made by 7 different colors. If you want 7 different colors to form back white light, you must move it at very high speeds, okay? And this is essentially how the experiment goes on. You see, when it slows down, you can start seeing the 7 different colors again, but when you speed up, you can see that it starts going into white light again, guys, indicating that white light from the sun actually has 7 different wavelengths. Really, none of you guys ever played this in kindergarten before? Oh, wait a minute. That's not the pandemic. I was thinking, oh, is it because of the pandemic? But that was like, probably what, 10, 15, 12 years ago when you guys were in kindergarten. All right, but anyways, yeah, this is one of the experiments that concludes that white light has 7 different colors. Okay. All right, so, oh, someone is asking something. What happens when the light comes back out of the prism? Oh, good. So when the white light, you mean the light comes out of the prism here? You mean from this stage here, is it? Okay, so what happens is, right, from this stage here, it will not go back into one white light, is because when white light enters here, by right, this was supposed to be the normal trajectory, right? By right, the white light should have been a normal trajectory here. But because it enters a different medium, the speed of light actually slows down. And when it slows down, it will be refracted into a different angle. So because the white light is separated into different angles already, right? When it goes through a different medium yet again, this time from the glass to the air component, it will yet again go through refraction, which will separate them even further. And this is essentially how the rainbows are formed. You understand what I'm talking about, Raj? Yeah. So it will not go back into white light. It will not. It will just be refracted further and further and further away. So like you can see the 7 colors are like refracted at a wider and wider angle here. Okay, so having said that, if you look at the statement here, when white light goes through a prism, it will refract. This effect is known as dispersion. Guys, this scenario here, when the white light changes angle, is known as refraction. The term dispersion is basically like white light dispersing into 7 different colors, guys. It is basically dispersing into 7 different colors. But the reason why dispersion is available is because light is being refracted here, guys. Very important, don't be confused. It happens because white light is a mixture of all the colors of the rainbow. Guys, you actually need to remember the sequence of the rainbow, guys. It's always red, orange, yellow, green, blue, indigo, violet. But for those who have a problem remembering the colors, you can remember the colors as a name. Okay, you can imagine the colors as some guy called Roy G. Biff. Okay, Roy G. Biff. If you keep saying it enough, Roy G. Biff, right? You can remember the colors are is red, orange, yellow, green, blue, indigo, and violet here. Okay, Roy G. Biff. It's like some English name, whatever it is, right? But yeah, this is one of the ways to remember the 7 colors. Very important, you need to know that. And needless to say, white light is made of different colors with different wavelengths ranging from 0.004 mm to 0.007 mm here. Now, it is no coincidence that all your emergency colors are red in color, guys. If you think about it, stop signs ambulance lights traffic light stop lights or whatever, right? All of them are designed to be red in color. Why? Is because red light actually travels the fastest, guys, even though it is just like 0.003 mm difference, right? But because humans have a reaction time of 0.7 seconds, what's essentially happening here is, right, when you have just a little bit difference in the speed, you give humans more time to react. Meaning to say, right, if let's say, for example, you're an idiot and you go change all your stop signs, all the emerging signs into red color, right? Let's say, for example, the back of your car, that's red color one when you step on the brake, right? But if you change it into violet color, right, what happens is it will travel much slower, like almost half as slow, because of the difference in the wavelength, right? And because of that, it's more likely for you to be prone to accident. That's why you see sometimes on the street, you see like all the cool guys, they modify their cars into different colors, and then the exhaust pipes that sounds loud as hell, but the cars are still moving slow as hell, right? It's actually very dumb, in my opinion. But of course, everyone has their own way of living, right? But to me, I wouldn't do that because I know the science behind it. Okay, so yeah, remember, guys, because red has the longest wavelength, it is essentially the fastest. When all light travels in the same, no, actually red light will travel faster. Red light will travel relatively faster, simply because of, yet again, this formula here, V equals to F lambda, assuming the frequency is the same, which is definitely going to be the same. Okay. Yeah. So, but not a lot, it's just like, 0.003 mm difference. So yeah, but it definitely does contribute to the reaction time. Okay. Then finally, the last part here, guys, before we go into the exercise. Melvin, why are you late? Tell me. Huh? Oh, hey, I saw a lot of helicopters and planes flying on the sky. I think they're like preparing for the Merdeka Carnival or whatever. I see damn a lot of helicopters flying on the sky, man, when I was on the way here. Roadblock. Or was it roadblock from your bed to the door? You went to what? Piano. Oh, okay. Where do you take your piano classes? Here, nearby here also, is it? Okay. All right, but anyways, finally, the last part I want to talk about here is basically monochromatic light, guys. The term mono means to say it's solo, one, right? And chromatic is essentially light, right? Monochromatic light means to say light with one single wavelength and one single frequency. Guys, in your exam, they will like to ask you this in either your paper 4 or your paper 2. They will ask you to define what monochromatic light is. I see the exercises are empty. Very good. Your kawan is there also. Guys, monochromatic, if they ever ask you this, you need to understand, you need to answer them. Monochromatic light are light with single frequency and single wavelength only. Single frequency and single wavelength only light are monochromatic light. Meaning to say, if today I were to shoot a red color laser here, it will not go through dispersion. It will only go through refraction. Means to say it will be refracted and then it will be refracted like this here. It will refract, but it will not disperse because there is no wavelengths for it to disperse, no different wavelengths for it to disperse, unlike white light, which has 7 wavelengths here. Okay, unlike white light with 7 wavelengths, monochromatic light will just go through refraction here. Okay, very, very important. Anyone don't know what I'm talking about? Good, excellent. Okay, so having said that, I hope everyone online has done your homework with the benefit of the doubt, of course. Okay, but anyways, yeah, look through here. We're going to go through the questions really. I see. Oh, bloody hell, do the work. You think you just look at this screen, you're gonna learn, bro. Yet it's not gonna work this way. You guys need to do the work, by the way. Anyways, going through the questions here. Figure 7.1 shows an object and its image formed by a converging lens. One ray from the tip of the object is shown already, right? So first and foremost, they ask you to take the things that describe this image, right? Look at this, the object becomes smaller in the image. So is this diminished or enlarged? Rachel, is this diminished or enlarged? If the object becomes smaller when it forms the image. Annie, it's definitely diminished. The object is larger than the image. It becomes smaller, right? So it's definitely diminished. It is definitely going to be inverted or upright, Xuan. Inverted, good, because initially it's pointing up, now it's pointing down. Oi, you trying to be Ju-on or something? Why are you hiding that? Sit, come on. What? Some. Okay, and then this one here is definitely going to Brill or Wojo. Melvin, Brill or Wojo, this one? Are you Melvin? Oh, did you say it? Oh, my bad. Yeah, it's definitely real, guys, because it's formed by real light. Very important. All right, then after that, they ask you to draw a ray passing through the principal focus of the lens from the tip, right? So what you're supposed to do here, right? You're supposed to have the idea of how the light is going to be. By right, it's supposed to be a straight line, cut through the focal point and find the image here, right, guys? But this time here, they do not give you the focal point. So what you have to do is you have to work backwards, guys. And when you work backwards, it means to say you're still going to draw the horizontal line, as all the real images you have drawn and the virtual ones, and you're going to cut through the focal point, but you don't know where the focal point is. But you know that this image can only be formed when the two light rays are converging, meaning to say you're going to use one ruler and you're going to draw one straight line down until you find the image. Wherever the light rays hit the principal focus, wherever the light rays hit the axis, that is going to be your principal focus, guys, which is essentially your focal point. Right. Yeah, I'm supposed to draw one straight line downwards only. So it is very important that you have the idea, the image in your head, guys. Then you can easily draw it here. Then after that, they ask you to determine the focal length. You are going to measure yourself from the optical center to the focal point here. And then whatever length that is with a ruler, that is going to be your answer. But I think it's going to be somewhere around 2.4 cm, if I'm not mistaken. It should be somewhere around there. But measure it yourself. Don't take my word for it, because God knows I don't have a ruler here. Right. Then, 2.5. Oh, yeah, somewhere around there. It will be somewhere around there. There will be a plus minus 0.1 mm. Sorry, 0.1 cm allowance, which is fine. Okay. Then finally, they ask you to draw another ray not passing through the principal focus of the lens that passes from the tip here. Guys, on a normal scenario, guys, pay attention to this. On a normal scenario, if they ask you to draw the third light ray, guys, you're actually supposed to draw the one at the bottom here, acting as the first one, but just inverse, right? It's supposed to be a horizontal line, and it's supposed to cut through here. But in this question here, they specifically mentioned it cannot pass through the principal focus, meaning to say you cannot draw this third light ray here. Instead, what you're supposed to understand is that the image can only be formed when the light rays are going to converge. So what you're going to do is you're going to draw one straight line here to the normal. You bend it because obviously it goes through refraction, right? Then you just go back to the tip of the image. This is going to be your third light ray, guys. Do you understand what I'm talking about? Okay. Right. Then after that, next part here. Oh, I figure, why are you drawing on the bottom, by the way? You're supposed to draw on the image. All right. Oh, sorry. For those who are not done drawing, you're supposed to draw one straight line, hit the normal, and then refract it a little bit to the tip of the image, guys. Because you understand that the image can only be formed where all the light rays are converging, guys. Very, very important. Please make sure you know this. But in a normal scenario, if they don't say it, you cannot pass through the principal focus. You just draw one here and then this here. This bottom line is just a mirror of the first light ray, guys, in a normal scenario. But in this question, they cannot. Okay. And moving on to the next part here. Describe the full description of this image here. Oh, Eugene, full description, what's this? What's the three characteristics of this image here? Virtual, upright, and it is magnified, guys. If you'll notice that a lot of your lens questions, they will always be with regards to this here, guys. This is essentially a magnifying glass. You must know that a magnifying glass, what's the characteristics and where should you place the object, guys. The object will always be placed in between the focal point and the optical center. Very, very important. As soon as you see that the object is placed in between these two things, right, for sure this is going to be a magnifying glass. So you should have a mental picture of this thing here, so that if they ask you to do it backwards, you know how to do it backwards as well, guys. Very, very important. And then use the letters on figure 7.1 to identify the focal length. Good. Abigail, what's the answer here? RS, excellent. Good, because you identify that this is the optical center and this is obviously a focal point. So answer must be RS, guys. It must be RS. Okay. And finally, draw the eye suitable position. Where will your eye be? If you refer to the notes, you'll notice that your eye will be exactly here, guys. it is exactly as the one you see here in the notes, guys. If you refer to the notes here, you see that your eye is going to be here for a magnifying glass. So in your exam, if they ask you to draw the eye, right, you draw the eye, which is essentially going to be here. Magnifying glass 是那些放大镜，你知道吗？就是 like if you look at the ant, it will look bigger in the glass, right? Because 这个就是 magnifying glass 来的。This is essentially the light rays of how the magnifying glass works. So if let's say you have a small little ant here, right? The light rays are going to go like this and go like this. That's why when you see, right, you see that at a certain angle, you see a bigger thing on the lens, right? It's because it is a virtual light that is formed at the back here. That's why it's like bigger. Yeah, but this is a magnifying glass. Always ask in your exam, by the way. Very, very commonly asked in your exam. You must know. You must have this picture in your head, because like out of the 10 questions that are magnifying glass, out of the 10 questions that are lens, at least 6 of them are magnifying glass. Very, very often asked. Okay, so make sure you know it's RS. Okay, then finally from here they ask you to basically draw the light rays, right? Which you already know how to do. It's always going to be the standard stuff. First and foremost, it will be a horizontal line, cut through the focal point. Then after that, cut through the optical center. Wherever the 2 light rays meet, that is essentially where your image is going to be formed. But of course, you need to use a ruler, right? Don't freestyle it, guys. You lose your marks. And it's 4 marks as well, guys. All right, then finally, they ask you to draw one more other light ray here. If they ask you to draw one other light ray, you can just draw the exact mirror of the first light ray, which is horizontal, cut through the focal point here, right? Now we're going to look something like this, right? It's going to be the exact mirror of the first light ray, guys. Just draw 3 of it and then you'll be fine. Okay. Don't start from the object, Rachel. Start from the image. Draw the horizontal line first for the third one. Yeah, until the normal. Then only you draw it towards the object. Yeah. Guys, one way to check whether your third light ray is going to be correct is by measuring the distance of the focal length, guys. If this distance here is the exact same distance here, then you are going to be correct. If it is not, then you are definitely wrong, guys, for the third light ray, because like I mentioned, it is just a mirror image of the first one. It's a mirror image of the first one, guys. Okay. You measure the distance between the focal lengths here and the focal length here. If it is the same, then you are correct. If it is not, then something is wrong somewhere. Okay. Usually, if it is wrong, right, it's most likely because this line here is not horizontal, or this line here is not horizontal. It must be horizontal. I mean, it must be parallel with the principal axis, right? Make sure you draw it parallelly. Yeah. Okay. Any questions from this part here? Okay, then the next part here, they say that a glass converging lens is used as a magnifying glass. Once again, a magnifying glass to observe a red ant. Figure 6.1 shows the lens and the principal axis, the two principal focus, F1 and F2 here. On figure 6.1, mark a point on the principal axis, label it A to indicate a suitable position of the ant. What did I say just now? Where should I place the ant, Xuan? Where should I place the ant if this is a magnifying glass? In between what? And the what? Yeah, the optical center. guys, it's very important you know how the magnifying glass works, guys. In order for anything to work as a magnifying glass, this is your optical center, right? This is where your image, your object should be. It doesn't matter where it is, but as long as it is in between the focal point and the optical center, then this thing here is going to behave like a magnifying glass already. And if you're uncertain, yet again, you can refer back to this diagram here. You see, where is the object placed? Oh, exactly in between the focal point and the optical center. This is the condition for it to work as a magnifying glass. You must know this. And if I say you must know and you still don't know in the exam, then you deserve to fail. And finally, last part here. Sorry, not last part. Next part here. Label E to indicate a suitable position of your eye. Yet again, that keeps telling you you have to have the mental image of where the eye is. You're supposed to have your E somewhere around here, guys. Yeah, exactly the same as your notes given you. Somewhere around here, it doesn't matter. Okay, but you know, if you draw the real light rays, it's gonna be like this, and like this, and da. But they don't ask you to draw the light rays here, so don't draw the light rays. But you should have the mental image of it. Okay, and finally, take one box to indicate where the image of the end will be formed here. Where will the image be formed, Melvin? Good, very good. It will be left here because your image should be exactly somewhere here. Right, Julian. Next one is you. Okay, 2 words to describe this. Obviously, is going to be real virtual, and it's definitely going to be upright for sure because these are magnifying glass, right? And they ask you, as the light enters the lens state, what happens to the wavelength? Obviously, the wavelength is going to decrease because the speed of light is traveling into a denser medium. The speed of light in air will definitely be the fastest. The speed of light in any medium will definitely be lower, guys. Very important, you need to know this. And because of that, when the speed of light is decreased, your wavelength is bound to decrease yet again with accordance to your V equals to F lambda formula. And finally, if they ask you about frequency, it's definitely going to stay the same, guys, because I keep saying this over and over again. It is as free as the free can get. The frequency will never ever change, guys. Frequency will never ever change. Okay, and say how the wavelength of violet light and red light differs. You're supposed to remember that red light travels the fastest, so the wavelength here is higher and the wavelength here is lower. So you're supposed to say anything along the lines. I say that violet has a smaller wavelength, red light has a longer wavelength, or anything along the lines. It doesn't really matter, but you must mention that the wavelength of violet is lower. Anything along the lines, paraphrase or whatever. Doesn't really matter. It's not an English exam. Okay. You're supposed to remember red light travels the fastest. That's why all your traffic light, all the emergency light are in red color. And the reason why red is fastest is because the wavelength is the longest, guys. Yet again, with accordance to the V equals to F lambda. Okay. Then moving on to the next part here. Okay. Now this next part here, guys, they say that figure 6.3 shows rays of violet and red light incident on prism. This is the red and violet light as labeled here, right? Now after that, it says that, hey, how do I get rid of this thing now? What the hell? This useless thing here. Oh, it's gone. Hey. All right, then after that, figure 6.1, blah, 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 the dashed line shows the path of the ray of the violet light. This one here is supposed to be your violet light, right? If you're uncertain, you can always label it in your exam. It's much easier. In fact, I do recommend all of you guys label your information properly, then you don't have to keep looking for the words and you panic a little bit in exam, and you're like, oh shit, where am I? You'll eventually be lost in your thoughts, guys. If you have information, label it, write it down, show an indication so that you can look at it and you know what's going on. On figure 6.3, draw and label the path of the red light it takes on the prism. A calculation is not required. Eugene, where should my red light be? It should definitely be above the violet because red light travels faster. But when you draw it above the violet, you don't draw one straight line like this. Bloody hell. It doesn't work that way. If you draw one straight line, you're indicating that the speed of light is going to be the same. It definitely doesn't work that way. You're supposed to give an angle a little bit and refract it a little bit. And it should be on top of the violet because it always Roy G. Biff, guys. Roy G. Biff, Roy G. Biff, Roy G. Biff, Roy G. Biff, Roy G. And then finally, this part here. This part is very, very commonly mistaken with the students. I'm going to show you the way to do it properly first. Then I'm going to show you the way that I will do it, which will guarantee you getting your full marks here, guys. If you look at the question here, it says that figure 6.1 shows an object O placed in front of mirror M. So this is your object is placed in the mirror. This whole thing is a mirror here. Two rays from the object to the mirror are shown. They already draw these two rays here. First and foremost, on figure 6.1, one of the rays are for one of the rays shown, draw the normal of the mirror. Guys, the normal is always going to be perpendicular against the surface the light touches. Meaning to say, you could either draw one dotted line here, or you could have drawn one dotted line here. It doesn't matter. You could draw either one. It's definitely fine. Then, after that, they ask you to mark the angle of incidence and label it X. You could have labeled this as your X. God forbid you draw this as your X. If I ever see this to you, and if I ever see this, I'll beat you for sure. And especially if you're in the center. You better by now know that the angles are always with reference to the normal, guys. It is not with reference to the surface. No, it is with reference to the normal, with reference to the normal. If you drew either one as X, it is definitely fine because they say either one of the rays, right? You better know this, right? Then you get your first 2 marks. Easy. Then after that, the next part here, they ask you, draw the reflected rays for both the incident rays. If they ask you to draw the reflected rays, what you're supposed to do is, you're supposed to see the angles here, guys. You know, like, because law of reflection says that the incident angle must be equal to the reflected angle, right? Meaning to say, if this one here took 2 boxes, this one here will take 2 boxes, and you're just going to draw one straight line all the way down. With your ruler, of course, you don't freestyle it. It doesn't work that way. And if you drew the second one instead, you see this one here will take somewhere around, I don't know how many boxes is this, like 6 times 3 or 7 times 3. So you're going to draw like 1, 2, 3, 4, 5, 6, 7, then 1, 2, 3. It'll be somewhere around here, right? And you draw a straight line and go all the way down as well. This will guarantee that your incident angle is the same as your reflected angle, same like this one as well. Your incident angle would have been the same as your reflected angle here, right? But this is not the end of the thing yet. Everyone draw this first. I think most of you guys got it wrong. Okay, then once you're done with that, the next thing you're going to do is you notice that the question says construct lines to locate the image of O and label this I. If you already have these lines and you know for a fact that the image can only be formed when the light rays are going to converge. If you draw this dotted lines here, you realize that, oh shit, the light rays are actually diverging. So I know that the image is definitely not going to be here. And if you think about it, can you stand in front of the mirror here and then like your image is somewhere around here, bro? Dracula or Edward Cullen going on or something is wrong somewhere. Right, which is definitely wrong. So what you realize that, oh, I need to draw the converging line. So what you're going to do is you're going to and then wherever you find the light rays, this is going to be the image form, right? Everyone try to do this first, and then I'll come back in 2 minutes to see how you guys draw it. Do it right now. Okay, do it. Alright guys, got it? That's wrong. That one was correct. Oh, still not done yet. Wait, that's wrong. That's wrong. That's wrong. Oh. Guys, I tell you what, this is a common problem with everyone, guys. Pay attention. You know what's the common problem? The common problem here is, right, most likely one of the angles somewhere here is wrong, right? And when you draw the dotted lines here, you'll find that your image is not even going to be directly above your object. Guys, if you think about it, right, if you're standing exactly in front of the mirror, the image will be exactly in front of you also, right? Why would the image be towards the left of you when you're standing in front of the mirror? Right, this is a very, very common mistake with a lot of students, and this is the reason why it is always good to cheat. So what you do is, right, you understand that, pay attention, everyone, don't copy first, pay attention. You understand that the image produced in front of the mirror will be the exact same distance of you and the mirror, right? Meaning to say, if let's say this is the object, and if let's say here to the mirror is, let's say 10 boxes, right? Your image form will be exactly above you. I mean it's going to look exactly above you, 10 boxes, and this should be where your image is, right? If you can understand this part here, you can work the whole light ray diagram backwards. So what you're going to do is, instead of doing the line, then dot, right? You do the dot first. You do the dot to hit exactly where it is. Dot to hit exactly where it is. Then only you draw the light rays here. If you do this 100%, it will be correct because your image should be exactly above your object if you are dealing with a mirror. Now only you do the dotted lines here, or the normals and everything, then you'll get your full 4 marks already. Anyone uncertain with what I'm talking about? This is a very common mistake with the students. Once even like a slightest difference in the angle here, you will be wrong already, guys. So my recommendation is, if you are ever to draw anything in the mirror, find the image first. The image will definitely be exact same distance of the mirror to the object, right? Then with that, just and you'll get your full image. Anyone uncertain what I'm talking about? This is very important. You'll see this. You'll probably see this in your exam as well. And once you draw your image towards the left or towards the right of your object, you're wrong already, straight away. Do you draw it the normal way and got it right? Oh, good. Show me. Oh, very good. Oh, no. Oh, yeah, it is. Gave you a shock there, didn't I? Oh, yeah, you're correct. Very good. Eugene, you can draw or not? You can draw or not? No. Let me know when your results are out so that I can abuse you verbally and physically. File it. I've got nothing to lose anyway. You think you can sue me? How much are you gonna sue for? You pay more for the lawyer fee, you fool. Right. How much do you think it's gonna be worth? How much do you think you're gonna pay the lawyer for my entire saving? I wouldn't do that trade if I were you, but you're free to try. Okay, guys, and with that method, then you get your image exactly above you. You'll get your full 4 marks, guys. You'll get your full 4 marks. Okay. Oh, this question should be here. I forgot to skip the page. Anyways, next part, figure 7.1 shows the principal axis of PQ of a converging lens with a center XY. This is the center XY. Means to say a lens is going to be like somewhere around here, right? And you know that this is going to be optical center. Then after that, this question here, they give you specific parameters, guys. You are supposed to follow the specific parameters. They say that the object is 2 cm high. Okay, this object is going to be 2 cm high. and it's placed exactly 2 cm to the left of the lens. So this should be 2 cm and this should be 2 cm, right? Then you're going to say, they say that the converging lens has a focal length of 3 cm here. This is yet again, what length will this be for again? Sorry? No, if I have a focal point here and then my object is here, what lens will this be for again? What type of lens will this be for? Yeah, it will be magnifying glass because the object is placed in between the focal point and optical center. Very, very important. Make sure you know this by now. Very, very, very important. Okay, then after that, just draw. You'll most likely end up with a super large image somewhere here. It's because it's not wrong. It's because this image is shrunken down when I was compiling the question. You'll have an image that is damn far away from the normal drawing. It's not wrong, guys. The only reason is because it's like this is because the image has been shrunken down and then yeah, the parameters stay the same, basically. You're gonna have like a damn big image now on the left. Oh, Eugene, hello, wake up. You draw already now. Oh, pretty good. I've mistaken. What do you say that word in English again? How to say yuan wang in English again? Okay. Anyways, moving on. You measure your distance of the image from the lens and height of the image for yourself. I don't know. And then here, this is the important part, guys. State whether the image is real or virtual. Eugene, will it be real or virtual? Why? How do I explain it? No, Melvin, how do I say this? Is it real or virtual? How do I explain it? Why? What the? Why? Damn right it is. Damn right it is. Everyone pay attention, okay? This is the free mark, exactly what I told you just now. It is definitely going to be virtual. Why? The answer is always because it cannot be projected onto a screen. Hey, this is a very standard question now. You bloody hell better know how to write the standard answer for this one here. Melvin. Make sure you know. And finally, the next page here. Description. Rachel, what's the description here for this image? Real or virtual? Real. Why? Formed by real light, is it? Can be projected on the screen on this one. So it's definitely virtual, guys. Dude, the dead giveaway here is always going to be the virtual lights here, guys. Once it is formed by virtual light, it is definitely virtual. One way you can remember it also is if the object and the image are on the same side, they are definitely going to be virtual, guys. It can only be real if the object and the image are on opposite sides, but you cannot write that in your exam. You cannot write that in your exam. It's just one way to remember it only. If they are on the same side, they are virtual. If they are formed by virtual light, it is virtual. Magnified, same size or diminish view. Same size, honey. This and this is the same size. There we go. You want me a video? Do you believe in equality with men and women? This bloody hell is the same size. Huh? What the hell? Which one is it supposed to be? Huh? Diminished. Which one are you comparing with? Is it from the image to the object or the object to the image to define whether it is magnified or diminished? Hello. It's an object to image. This is essentially a magnifying glass. You know why they purposely put this like this? Because I think at some point, most of the students would have remembered a virtual image of this, right? But if you flip this thing exactly 180 degrees, this looks a little bit more familiar, doesn't it? And this is definitely going to be a what? A diminishing lens. It's a magnifying glass, and because of that, it wouldn't be much of a magnifying glass if the image was the same size or if it was diminished, would it now? You understand what I'm talking about, right, Abigail? Yeah, and then this one here, I made everyone answer me already last week, right? So it's supposed to be A to B, guys, because this would have been optical center, and this would have been the focal point. Okay, guys. Look at this guy; he's ready to go already. Never so fast. We're back to all packed. Okay, guys. Okay, everyone. I have a little bit stuff for you guys to do here before the end of the day. It's an optional thing. It's for you to enhance your understanding, right? You go to this page here, right? I would like for you to do a little bit before we enter the next class next week. Guys, next week we're going to be talking about electromagnetic waves already, guys. Electromagnetic waves means to say it's like this is absolutely a new chapter. I would like for every one of you guys to go to this website here, which I've shown 1,000 times. Go to the lens. Go to the lens exercises and do 4 of this, guys. I'll even take the time to copy paste the note here. Copy paste here. Please access the files, do the exercises. It is a great way for you to enhance your understanding. And there's answers provided there as well, guys. So please do that before next class. Then we're going to move on to the next chapter already, guys. Okay. Having said that, that'll be it for today, guys. I'll see you all next week. Goodbye. Goodbye, everyone.
Bye.
Bye-bye.